Hey, sixth grade. So we have progressed to lesson 83. Now this lesson, you'll find it on page 575 of your textbook. You may want to read through it. It's always a good thing to do. Because remember, I'm just kind of streamlining and getting to the gist of everything to make it a little quicker for you. But as you see, it starts out and it talks to you about when we have say factors of 10 and when we're multiplying them. So say that we have 10 to the third power times 10 to the fifth power. What do we do with that? When we're multiplying and we have the same bases, we are allowed to add the exponents. Okay, so just want to remind you of that. Because I could write 3 factors of 10 and 5 factors of 10, so I'd have a total of 8, but it would take me a long time to do that. Okay, so when you have the same bases, you can add the exponents when you're multiplying. Well, that's going to come in really handy with multiplying numbers that are in scientific notation. So as you see, your first example has 1.5 times 10 to the fifth, and I'm multiplying this by 3 times 10 to the seventh. So what I want to do is multiply the number part. Okay, so 1.5 times 3, well, that's like saying 3 times 15. So it would be 4.5, all right? And if you don't know that in your head, you can work it out. And then the factors of 10, I just add the exponents. So this would be 10 times 10 to the 5 plus 7, 12. Okay, so what am I doing again? Multiplying the number parts, putting the answer, times 10 to the adding the exponents. Now make sure at the end that this is in proper form. This is. Remember, scientific notation has one non-zero digit to the left of the decimal. So here we go with the perfect answer. All right, let's try the next one. As you see, example 2. We've got 4 times 3, okay, that's 12, times 10 to the 6 plus 5, 11. Now, is this in proper scientific notation? No. Remember, there's an implied decimal at the end. If I don't see the decimal, I know it's at the end, and I have to put it in the proper spot. It has to have one non-zero digit to the left. So I have to move that over. Now, when I move to the left, I increase my exponent. So I've moved to the left. I'm going to increase this by 1. So it'll be 10 to the 12th. This is our final answer. All right, so let's look at example 3. We have some negative exponents. So we've got 2 times 10 to the negative 5, and we're going to multiply this by 3 times 10 to the negative 7. So remember, we multiply the number parts. So 2 times 3 is 6, times, oh, they're actually using dots, so let me make sure I do the same thing. And 10 to the negative 5 times 10 to the negative 7 would be 10 to the negative 12. And this is in proper form. All right, let me do one more. We've got 5 times 10 to the third times 7 times 10 to the negative 8. Okay, so 5 times 7, 35, times 10 to the 3 plus negative 8, negative 5. This is not in proper form. So I know there's an implied decimal at the end. I'm going to move it 1 to the left. Left increases, so I'm adding 1 to this exponent. So I get times 10 to the negative 4. And that is our final answer. All right, so that was short and sweet. I want you to go to the practice. I'll be putting them up here. You stop the video and then come and check them, okay? you do not have to do E. Oh, you're not quite finished. So I'm going to go ahead and show D just in case you need a little boost. So 6 times 7 is 42, times 10 to the negative 7. I'm adding the exponents, but this is not in proper form, so I have to move 1 to the left, which will add 1, and that will be negative 6. Okay, so check Red Web for your assignment. I hope you all are doing well. I miss your smiling faces. I'll look forward to seeing you on Zoom when it's time on Fridays. God bless you. Hang in there, gang. Love you so much.